the numbers on the graph.
Hey everyone, Mr. Schachter here, back with a extreme value example that doesn't really work like the rest of them. So this graph is weird. And the reason why this is weird is because we're used to graphs going up and down infinitely. And this one doesn't. And that's going to affect our answers here. As we work through it, I'll kind of try to explain. So let's start with local maximum. So we scan the function here, and we got a point right up here. This is a local maximum. It is the top of a mountain, all set. So we've got, this guy is 1, 4 local maximum. Okay? Now, if you look for local minimums, you might be tempted to pick something over here. But actually, because it is a flat line, a straight horizontal line, it is not a local minimum or a local maximum. This graph actually has no local minimums. There isn't a place in this picture that is the lowest point if you look left and you look right. It doesn't have any local minimums. Okay? Let's try domain. Well, this extends infinitely in the negative infinity direction and infinitely in the positive infinity direction. So the domain is going to be infinite, negative infinity to infinity. So this covers everything. You might want to say the range does too, but look, -4 is covered, 0 is covered, 3 is covered. But once you go past 4, there is no more graph up here anymore, no graph up here. What that means is the range actually has a stopping point. We begin down at negative infinity, and we will eventually stop at 4. Right here, that top highest point, 4. Because 4 is included in the domain, we have to make sure, or the range, so we have to make sure we use a bracket. We would not put a parenthesis on 4, because that would mean that 4 is not actually included in the function. But it is, because it has a nice, clear, solid line. If it were an open circle, it would have been a parenthesis. All right, so keep a lookout for problems like that, and solve the next one.